In our usage, an error stack occurs when more than one source of variation lies on top of another, creating a much larger error than would otherwise occur. If we remeasure the standard every time we measure a production sample, we introduce measurement variation. A very small amount may be due to variation in the instrument itself. This amount might be as high as 0.15 delta E. While the instruments themselves are quite repeatable, there is a human factor to consider as well. This can add another 0.35 delta E. It is not possible to measure in the exact same spot every time. As precise as we try to be, print production variation combined with substrate variation will add another 0.25 delta E minimum. If we are using different production samples in different locations, even if they are all samples pulled from the same run, one after another, a significant variation will be found, as much as 1.0 delta E. What this means is that when using an instrument to compare a production sample to a standard, the standard value itself is going to vary as much as 1.75 delta E. This is assuming that we are using brand new standards that have not aged. If they have aged several months or more, this variation will be even greater. In some cases, this means that the sampling error for the standard is as great as, or even more, than the allowable production tolerance. Some people have tried to minimize this aging effect by creating new standards during each run, but this also increases the variation as we are constantly chasing the last production. Sometimes the impact is worse than using an aged standard. The answer to this dilemma is to use digital color standards. QA software, such as ColorCert QA tools, makes this easy. Digital standards are precise, never change, do not age, are the same for everyone, are objective, and do not contribute to error stack.